In this video, we're going to talk about the circumference of a circle. We're also going to talk about arc length, which is a piece of the circumference. So we're going to start with the circumference, which means we need a formula. I can use both of these formulas to find the circumference of the circle, where D stands for the diameter and R stands for the radius. Now, depending on what's given to me in my examples may help me decide which formula I'm going to use, or I can use what I know about diameter and radius to use either formula. So I'm going to start with this first one, where I can see the diameter is 20. Because it goes all the way through the center, I know it's the diameter. And if I'm going to find the circumference, I'm going to use this formula because it tells me the circumference is whatever the diameter is times pi. So in this case, my circumference is 20 pi. And we are leaving our answers in terms of pi, which basically means we are not going to convert it to a decimal. Sometimes we will, and sometimes we won't. But most of the time, we're going to leave it in terms of pi. So this second example here, where you see the radius is 3, well, I am going to find the circumference of that circle as well by using the other formula. And this formula is basically the same exact thing, except I'm just doubling the radius, which is what gives me the diameter anyway. After I plug in the radius, I want to go ahead and simplify. So I get the circumference is 6 pi. Before we continue, we want to make sure we understand a few things. When we're talking about circles, we talk about circles in a lot of different ways. Sometimes we talk about it in linear units like feet, centimeters, meters, inches, miles, and sometimes we talk about circles in degrees. And when we're solving problems with circles, sometimes we need to work with both units in a proportion. So it's good for you to understand how we use them. So first of all, when you hear lingo like arc length, that has to do with the circumference, which means the actual length. So this would be my linear units like feet and meters and inches and so on. Now, if you hear me say arc measure, well, now I'm not talking about length in feet and inches, I'm talking about degrees. So for instance, this is an arc, and notice this central angle here is 90 degrees. Well, central angles are equal to their arc measures. So if this angle is 90, that means that this arc measure is also 90 degrees. Now, the whole circle we know is 360, so that means that we can always find portions of the circle because we know the total is 360. Just like we know the total distance around is the circumference, and the arc length is a piece of that circumference. In this example, Carly had the slice of pizza on the left. Its angle measure and length are marked. So just in case you can't see, this angle measure right here is 40 degrees. And it does have the length of the pizza to be 9 inches. It wants to know what is the length of the crust, and if the pizza was cut into equal slices, how many slices would be in the pizza in total. So we need to do a couple things here. And this is a problem where we need to understand the relationship between the arc length and the circumference, as well as the arc measure, and the total degrees around a circle. So we're going to set up our basic proportion to solve these types of problems. So as you can see here, the proportion on the left-hand side, I'm talking about the linear units, the total being the bottom, because the circumference is the total distance around. So the numerator is the part of the total, equals my arc measure, which again, you know, the 360 is the total around, and your arc measure, which in this case would be like the red, is just the part of the total. So we're going to use that proportion to help us solve lots of different types of problems. Now in this case, we are trying to solve for the pizza crust, which is the arc length. Okay, so we are solving for the numerator in this first equation. So since we don't know what that is, we're going to label it with a variable. But the next thing I need to do is compare it to the circumference. Well, the problem didn't give me the circumference, so I'm going to use what I know to find the circumference. So based on what we did in the beginning, where I had C equals d pi, or I had C equals 2 pi r, I can use one of those formulas to find the circumference of the entire pizza. Now it's important for you to visualize this pizza because this is not the diameter of the entire pizza pie. As you can imagine, there's another slice of pizza over here going all the way around. So this 9 is actually the radius. So in order to find the circumference, I'm going to use the diameter, which would actually be 18. If I double that 9, so I know that my circumference is 18 pi. So I'm going to put that in the denominator. Next, I'm going to compare the arc measure to the total 360. And the arc measure they gave me was 40 degrees. Now, once I'm here, I'm just going to cross multiply to solve this proportion, just like I've done in the past. So you can see I get 360 times x equals 40 times 18 pi. I'm going to go ahead and multiply the 40 and the 18, and I get 720. And then the only way to get x by itself in this case is to divide by 360. So x is going to equal 2 pi. Now I want to be able to actually answer the question because it says how long is the pizza crust. So I don't want to say the pizza crust is 2 pi inches. So I am at this point going to convert my pi to 3.14 and get an answer. So my pizza crust is equal to 6.28 inches. Now last but not least, it did ask also how many slices would be in the pie in total. Now what I can do here is, well, if one pizza was a 40-degree angle, I know that the total degrees in a circle is 360. So what I can do is I can say 360 divided by that 40, because one slice of pizza was 40 degrees, and I can see that I'm going to get a total of 9 slices. 5 streets come together at a traffic circle, shown below. The diameter of the circle traveled by a car is 200 feet. So I know that from there to there is 200 feet. If traffic travels counterclockwise, which means I'm going that way, what is the approximate distance from East Street to Neponset Street? So from East Street all the way to Neponset, I want to know about how long is that. So there's a couple things I need to do. First of all, I need to find the circumference of the circle. Since the diameter is 200, I know that the circumference is going to be 200 pi. And now that I know the circumference, I can begin to set up my proportion. So I know that the piece I'm looking for is X, and that's a part of the total. The total is 200 pi equal to, I know the total degree is 360. So now the question is, how much are these degrees? What is the arc measure here? Well, I know that a semicircle, which is half, is 180 degrees. And I can see here that from Maple Street to East Street, it's a 40-degree marking. So if I want to find the arc measure from here to here, I'm going to just take 180 minus the 40, and I'm going to get 140 degrees. So I'm going to put 140 as my part of a whole. At this point, I'm going to cross multiply and solve. And begin to simplify. In order to solve for x, we are going to divide by 360. Now, if you put this in the calculator, you're going to get 77.78 pi. But then, of course, we want to make sure we actually answer the question, and answering the question in terms of pi doesn't really make sense here, so we are going to convert to a decimal. And it gives me approximately 244 feet. Now, since the instructions didn't say round, that's why I'm using the approximate indication here.